Hello, Roger Liu here with another Virtual Cities Unity 3D tutorial. And when we left off last time, we finished incorporating job skill into the human component. And now I'd like to go over some of the changes I made to kind of calibrate job skill. So to begin, instead of taking the arithmetic mean, where I added up normed intelligence, experience, attainment drive, and normed education, now I'm taking the geometric mean. So with the geometric mean, instead of adding up all the numbers and then dividing by their count or the number of numbers that you have, you multiply the numbers together and then you take the nth root of the numbers. The main reason I want to use the geometric mean here is because if you recall from last time, the lowest job skill was still fairly high. It was like 0.4, and the highest job skill was around 0.8, and I want to increase the range so it is as close to 0 to 1 as possible. And so with the geometric mean, because we're taking the product of the numbers, the humans really need to be good in all the dimensions that influence their job skill in education and experience, in attainment drive, and whatever the last one is. I can't remember off the top of my head at this moment. And with the geometric mean, the results will always be less than the arithmetic mean. So that is one advantage. And it's also good for when you have to like combine several numbers together to form a single figure of merit. Although usually this is more important when your factors are not normalized. In our case, they already are normalized. But I'll show you in the dataset how the geometric mean helps us out. Alright, so before we move any further, I'll first show you how we're calculating the geometric mean. In the miscellaneous class, we now have a public static float method named geometric mean that takes a array of floats named x and then returns a float. So we calculate the product of the values in x by first declaring a float named prod equal to 1, and then we loop through every single value and we multiply it times prod. Then we take that product and we take the power of it to 1 over its length. So that's equivalent to what this is saying here. We take the product and then we take it to the power of 1 over the count, the number of numbers. And then the other thing I changed is that I'm normalizing intelligence between 55 and 130. 55 is 3 standard deviations below the mean, and this is partly due to the fact that we're using the geometric mean up here now. So now if their intelligence happens to be 2 standard deviations below the mean or lower, they end up with a 0 for their normed intelligence, and then they end up with a 0 job skill. So this just makes it so they won't, they'll be above 0 most likely. I've also changed experience, so now their experience maxes out at 50. And I've changed attainment drive by maxing it out at 2,000. So basically, like if the monthly cost of your residence is 2,000 or greater, then this becomes 1. I've also changed how education is calculated. So even though we use the mean and standard deviation that we found online, they weren't giving us an accurate representation of the percentage of individuals that had bachelor's degrees and master's degrees and doctoral degrees. When I calculated the numbers, it was something like 17% had a bachelor's or above, and that isn't even close to being representative. I think that was because the distribution is somewhat skewed. There's the tail between 0 to 12 years of education is pretty thin. Then there's kind of like a big clump on the other side of the average. So basically, if we look at Wikipedia, this table here is showing educational attainment by degree. And basically, I'm using this table to fill in for humans ages 25 and over. So if your age is less than 25, then we're essentially calculating education like we were before. If your age is greater than 25 or 25 or above, then we're drawing a random number between 0 and 100. Probably makes more sense to do it like this now that I see it. And then if R is less than 3.27, then you fall into this category. You have a doctorate or professional degree. And so I'm assigning this an education of 22. That's assuming 13 years of K through 12 plus another 9 years of education. If your random number is less than 11.77, then that's assuming that you have a master's degree and your education is set at 19. If your random number is less than 31.96, it's assuming you have a bachelor's degree and you get an education value of 17. Then there's this group that's some college. And so for that group, we're picking a random number between 13 and 16.5. And then lastly, 88.31 have at least high school diplomas. So if you fall into that, then your education gets set to 13. And this works because we're using if, else if, else if, else if. So if R is less than, say R is 1, then we would go into here, assign education, and then we would skip the rest of this. Or say R is greater than 3.27 but less than 11.77. So say R is 6. Well, this would not be true, so then you would move to this line. This would be true, so then education gets set to 19, and then you skip the rest of this. So that's kind of what makes it work. So assuming that R is greater than 88.31, then we fall into this else statement, and then that's it. That would be less than a high school diploma. So because high school is 13, it has to be less than 13. So here what we're doing is basically what we're doing up here, except now the condition that has to be met is education. If education is greater than 13, then we have to keep redrawing until education is less than 13. And then there's also one small change here. If you're a child under 5, then you ended up having a negative education because this is calculated as age minus 5. And we're really just interested in formal education. So we basically want to clamp that at 0. Alright, so let's take a look at what this actually looks like now. And I'll start by selecting this data and then sorting by human type. And then I'm going to sort by job skill. And so we can see that the adult with the highest job skill has a job skill of 0.929. Not quite 1, but fairly close. And then if we look back at our at the order of our columns, from column D we have age, intelligence, education, attainment drive, experience, and job skill. So this person has an experience of 1. They have a master's degree because that is 19. This is their attainment drive, so they live in a fairly nice place. And they have an IQ of 112. So that's, kind of how it's working there. And then if we look back at the other end, this person has an IQ of 90. They did not graduate high school. They have a fairly low attainment drive. They have very little experience because they're young, and then therefore their job skill is fairly low. Um, so when we actually look at the distribution of this, and create a histogram here, give it this input range, specify that we want it on this sheet, and that we want a chart output. And we can see that we actually get a fairly normal looking distribution of job skill. And then when we set up the jobs, we just kind of need to remember that individuals with a job skill over 0.9 are going to be fairly rare. Suppose we could also calculate the average and standard deviation. So we have an average of 0.54 and a standard deviation of 0.14. Okay, so now that our job skill measure is reasonably calibrated for our purposes, we can move forward with building workplaces. Okay, we're back in Unity, and I went ahead and created a factory prefab. Basically what I did is I took a house, placed it at 250, 250, changed the scale to 90 by 90, and then I took off the residence script and I created a workplace script. I also created a new shader for it in the materials folder named workplace. Basically saved you the tedium of watching me do it, but now we can move forward to filling out the function of the workplace in the workplace script. So in our job script, we'll want to get started by creating a job class. And the idea is that in the inspector, we want to be able to go to the workplace and then define all the jobs that exist at that workplace. So the jobs could be things like CEO and factory worker and janitor and all the jobs that could potentially be there. So to do that, we'll create a public class, and we'll name it job. And then we need to define all the properties that we need for the position. So a job title would be good. We can just call that title. We'd also like to know how many employees can hold this particular position. So you might have a CEO, and there can only be one of them, or you might have factory workers, and you might have like a couple hundred of those. So we want to be able to specify that. So I'll create an int named num job positions. And then we also would like to define a salary range. We can use a vector2 to do that. A vector2 basically holds two floats. It does a lot more than that, like has a lot of linear algebra built into it, but we'll just use it to hold two floats. And it shows up in the inspector, that's why it's nice here. Alright, then we'll also need a list of employees. And then I need to import system.usings.generic. And our list of employees will be a list of humans. Alright, so that should be good for now. We'll probably have to expand that as we go. And then to make it show up in the inspector, we need to do system.serializable. And we need to define a public list of jobs in our class. So actually this needs to be outside of our class. And then inside of our class we'll have list of job, and we'll call this jobs. Okay, so we can go ahead and see if this shows up in the inspector. Alright, let's see if this guy refreshes. Maybe we did something wrong. Okay, yeah, this list needs to be public. Let's try that. Alright, so it seems like that. So now we can define 3 jobs in here. So the first one we could call CEO. Let's say that there's only one of those. Let's define a salary range of 85,000 to 110,000. And then right now there's no CEO assigned. That's why the size is 0. Then maybe we'll have managers. And say that we have 10 of those. And they have a salary range of, say, 60,000 to 80,000. And another thing that we need to define is the minimum job skill required for these particular jobs. So I'm going to go back to my workplace script and then define a public float min job skill required. Alright, so now we have this field in here. And so for the CEO, I'm going to do 0.9. For the managers, let's do 0.65. And then we can do factory worker 1. And let's say that there's 200 of these positions available. And the minimum required job skill is 0.05. So pretty much anyone can get this job. And we can make the salary range basically minimum wage. So we'll do 15,000 an hour. That's 15,000 a year. That's a $7.50 an hour to, say, 22,000. And maybe we'll do one more. So we can do factory worker 2. Maybe there's only 100 of these, but they require a skill level of, say, 0.2. And they can make more money. Well, say 23,000 to 30,000. That way there's a 7 grand spread there and a 7 grand spread there. Alright, so now we have some positions defined. So basically the way we want this to work is we want the employees to be able to search for jobs. Like, basically go around, ask all the workplaces for available positions, and then select the position that they think is right for them. To start, it'll just be the position that they're actually qualified for and that they'll get paid the most for. So inside of the workplace class, we need the workplace to be able to give a human a list of available positions. So we can define a method to do that. And we can call it public, and we'll return a list of jobs. And then we can say find open positions. Or maybe we'll call it get open positions. So basically what we want to do is create a list to return. And then we just need to loop through each of the jobs in the jobs list and see whether all the positions have been filled or not. So we can do for each var job in jobs. And then we could actually create a property in here that will tell us whether the position is open. So we'll call that open positions. And then basically we need to return employees.count is less than num job positions. Oh, and then this needs to be in get. So then in here we can do if job.openPositions, or let's do position available. All right, so if the position is available, then we just open it to this open positions list. So basically we loop through every job, and then if there's positions available, we add it to this list. And when we get to this point, there's two things that could happen. Open positions could be empty, and in that case, I think we should just return null. So we can do if open positions equals, or well, we'll do dot count equals 0. So nothing's been added to the list. Then return null. They'll just be easier to check and nicer for the garbage collection. So there's this system that goes around and cleans up variables that we define and are no longer using. That's called garbage collection. So if we don't have any references outside of this loop, it'll just make it a little bit easier for that. So if there are no open positions, then we return null. And we could type else and then return open positions, but we can actually just do return open positions, because the only way that we'll get to this point is if we don't return. So we don't actually need to put else there. All right, so now we can kind of turn our attention to the human script. In the human script, we need to seek a job. So let's actually create a function named seekJob, and this will only be called from inside of the human script, so we don't need to make it public. And basically what we need to do is find all the workplaces. So we can do that using the transform.findObjectsOfType method. Then we want to iterate over every workplace. So we can do for each var workplace in workplaces. Then for each workplace, we need to get a list of available jobs. So we can call the method that we just created. Get open positions. And then basically we want to search or iterate over each job. So for each var job in jobs. And we need to check whether we're qualified for the job. So we can do if our job skill is greater than or equal to the job.min skill required, then we're qualified. So I could even put like we are qualified. And so once we get to this point, we need to start remembering this job, and if this is better than any other job that we've encountered, we need to remember to apply for it. So before we start iterating through the workplaces, we can define a job best prospect, and let's initialize this to null. And then we also want to save the best salary, because that's what will determine which job is the best. We could also incorporate other factors such as the distance from the person's home to the job site, but for right now let's just worry about salary. So this will be float best salary equals 0. And so based on our job skill, we need to figure out what our salary would be. And we can actually just ask the workplace for it. So inside of the job class, we can create a method to calculate the salary for the position based on a person's job skill. So this will return a float, and then we'll call it calculate salary, and we'll pass it a job skill. And then if the person's job skill is less than the salary, then they're not qualified for the position. So then let's just return 0. So basically at this point, we know that their job skill is at least the minimum job skill. And we know that their job skill is constrained to 0 and 1. Actually, it may not be, but we should set it up that way if it's not. Okay, yeah, so here let's do math f dot clamp 0, 1. All the other values are clamped between 0 and 1, so this is probably a little bit paranoid, but there we have it. Basically, like if you have a job skill of 1, then you should get the maximum salary specified for this job. If you just have the minimum required job skill, you should have the minimum salary. So we can use mathf.lerp to do that. And the values we want to interpolate between are the minimum and maximum salary range. And to get those out of the vector 2, we can do salary range.x. So that's the minimum salary range, or minimum salary. And then we can do salary range.y, and that'll be the maximum. And then t is a value between 0 and 1, so we need to normalize our job skill between the minimum job skill required and 1. And then we need a name for this variable. We'll call it t. And then here we can put t. So if we go back to our human seek job function, after we determine that we're qualified, we can get our salary. We can say var salary. Well, it's really our like prospective salary, but probably close enough for this. Oh, and then we need to tell the workplace what our job skill is. So this is, I guess, kind of like submitting an application. You say, hey, I'm qualified for this job. Here are my skills, and they say, okay, well, we can offer you a salary of blah. So now, if this salary is greater than this salary, then that's looking like a pretty good option because, well, anything is greater than 0. That's why I set this to 0 to begin. So we can say if salary is greater than best salary. Maybe I will change this to prospective salary. Or I'll change this to salary offer. I like that better. So if our salary offer is greater than our best salary, then we need to remember what job this is. So then we would do best prospect equals job, and that's from this loop. And then we also need to remember we need to update best salary so that we're making valid comparisons as we go along. All right, so if we're qualified, then we apply basically and figure out what our salary would be. And then if our salary offer is better than our best salary, then we remember the job and we update best salary so that the next time we go through, we're comparing against the best salary that we've seen. So at this point, we've gone through all the workplaces and all the jobs at the workplaces, and we basically want to get hired for the position. So we can do if job prospect or the best prospect does not equal null, So we set this to null to begin with. So if this is not null, that means that we actually found a position that we're qualified for. So in this case, we want to accept the job, and we need to create a method inside of our workplace to do that. So inside of job, so we could actually call this apply. That might actually make a, and that should update in here. And then in the event that it returns 0, 0 is not greater than 0, so then best prospect should say null. And we need a semicolon there. And then we can create another one called accept offer. Alright, let's call this. So it's a method of the job, so it should be a verb. So let's call this hire. And then we'll need to know who the applicant is. So we'll say human, and we'll say applicant. To hire them, basically we need to add them to the employees list. And then we want we want the applicant to remember where they work. So we need to go back to here. Maybe I'll actually just put these side by side. So we want our human to remember where they work. So we can create a public workplace. And here we can do applicant dot workplace equals, and then the job doesn't actually know what its workplace is, so we need to create a reference for that. And then we'll actually need to find that on start. So then here we can do for each var job in jobs job dot workplace equals this, because this is inside of the workplace. So then here, when we hire the person, we can set the applicant's workplace, basically this value, to workplace. And then the human needs to know not only where they work, but they need to know what their job is. And to accomplish this, we can declare another value that'll basically store a unique ID for the job. And we can use a system GUID. And a GUID is basically a string of letters and numbers that we can generate randomly and have like a really high probability of being unique. So here we can do system.GUID.new GUID. Oh, and then we'll need to give it a name, so we'll call it a unique ID. And likewise in the human script, we need to store these. We'll call this job unique ID, so it's a little less ambiguous. Then in here, we need to remember that ID. And that's basically all it takes to hire someone. We might also want to check that that they're actually qualified and that the position's still open. If, then we can do this. So if position's not available, or the person's not qualified, so that would be applicant.job skill is less than min skill required, then we'll debug.log we might as well use a string format at this point. So what I want to say is air hiring whatever the person is for whatever the position is at whatever the workplace is, and then I can fill those in. So applicant dot name, and then that'll be title, and then workplace dot name. And then actually instead of debug log, so debug log will just spit out to the console the error message. We could actually throw an exception, and so that would actually abort running the rest of this script, which is really the effect that we want to have here. So then we could do throw new exception. Maybe we want system.exception. Alright, there we go. Okay, so here we actually have to hire. So this is basically this would be this. So this is basically the person accepting the job offer that they received. And then we're not actually calling job seek, so that's the other thing that we need to take care of. So we don't really want everyone applying at once, so we can use our time controller events to only apply like on day changes, for instance. So we could do time controller dot on day change handler, and then we can add the method, which would be seek job. And then no overload for seek job matches delegate. So that basically means that here we need to do int day. That's what this on day change handler is expecting. It's expecting a method that takes a single integer. All right, so we probably don't even want to, at this point inside of seek job, we probably want to decide whether we actually seek the job or not. So we could flip a coin to do that. So let's say var rand equals random dot range. Draw a number between 0 and 1. If rand is less than attainment drive. Okay, so yeah, if this is true, so this is a random number between 0 and 1. This is a number between 0 and 1. So when this is higher, it's more likely that this would be true. So if this is true, then we would want them to go through this entire job seeking process. But really, it's easier if we just return if this is not true. So we could just flip this, and then we could say return. Okay, so I think that's everything. I'll also show you a little trick. We can actually debug, or use Visual Studio to debug the code. So we can click this attach to Unity, and basically we want to know when we get to this point. So if I go back to the editor, I can hit play, and if it reaches that spot in the code, it should break. So I think our day is actually set, our time controller set kind of low, so we Right, so our hours are on 16, 17, 18, 19, 20, 21, 22, 23. Oh, so it looks like we didn't actually attach. Okay, let's set this at 2 so we don't have to wait as long, and then we'll play again. And we broke. Alright, so now if I hover over this, I can actually see the value of these things. So this is null because we haven't actually ran this line of code. But if I go up here, I can do step over, and now this is defined. So now I can see, okay, there's one workplace, and I can step through. Now I'm inside of this for loop. Workplace is factory workplace. I got the list of jobs. There's 4 of them. You can even open these up, and these match what's inside of the inspector. It's basically okay. So we found a job that we're qualified for. Our job skill is 0.53013, and this is a factory worker 1 position, so we're qualified. Now we're going to get the salary offer. So say we actually want to go into this function. Instead of step over, we can do step into. And now we're calculating our job skill, apparently. And our job skill requires going through each of these properties and having them calculated. Now we're calculating the geometric mean. Alright, and now we're in the apply function. So we pass this test. T is getting calculated as 0.5, so we're basically right in the middle of the salary range. So our salary offer was $18,537 a year. And our best salary is currently 0, so that is better. That should be true. So we should remember this job. So we've remembered the job. Then we set our best salary offer. Alright, so now we've made it through the search. This is not null. So we should get hired for this position. So I did step into, now we're over and hire. This is just double checking that we still get hired. Guess it's a little inefficient because you actually have to go through all that code again to calculate job skill. So we added the employee to the employee list. We've also added the workplace to the applicant workplace variable. That way we can look at the human and then figure out where they work. We should probably actually do the same thing with residents if we're not already. Okay, yeah, they already have a reference to the residents. And they're done hiring. So if we no longer want to debug, we can hit continue, and it'll essentially run like normal. So now if I click on the factory, oh, so the debugging can also make it so your editor doesn't respond. So you have to do one or the other, basically. That we'll have to look into. Not sure what it's doing there. So if we look at our workplace script now, we can see that we actually have a CEO. So this is adult 688158, and there he is. We can see that he works at workplace. He has a job skill of 0.9388, an intelligence of 125, and education of 17. So yeah, they're actually getting hired now. We can see that we have 200 factory workers hired, and we have all of our managers hired. So basically, our workplace is 100% filled. Okay, so that null reference is because our workplace is calling, or we're asking the workplace for open positions, but if there's none available, then it returns null. So we need to check that here. So if jobs equals null, then we're basically out of luck. So we can return, or we are basically aborting our search at this point. Okay, and so the last thing we need to do is have the workplace actually pay the employees. And we can do this by creating a method in the workplace, something like do payroll. So void do payroll. And we can launch that much the same way that we're doing seek job. So this would be done monthly. And then this would be time controller dot on month change handler plus equals do payroll. So when the month changes, then this gets called, and then we would basically iterate through every single job. So then we would do for each var job in jobs, and then we would iterate through all the employees. So we would do for each var employee in job.employees, and then we need to pay them. So then we would do employee plus equals, or employee dot wealth plus equals what their salary would be, which we would need to calculate. Salary, let's see. So, so actually we should make this a, well, we could just call it apply, I guess. Or what we can do is we can do public so our apply method actually returns the salary. What we should do is maybe create an alias for this. So we can do calculate salary. Maybe we'll actually do it this way. So these essentially do the same thing, but it makes it less weird down here because we don't have to do job.apply to get the salary. And we could get rid of the alias completely if we just did this. And I think this is actually how I originally had it when I did this before. All right, so yeah, I think that should work, and we could actually get rid of these extraneous brackets in this case. Oh, actually, this salary is calculated annually, and we're paying them monthly, so then we'll need to divide this by 12F. Okay, let's return to payroll and just kind of double check this. So salary is actually their annual salary, and we're paying them monthly, so then we'll need to divide that by 12. And then we have some extraneous brackets here. So if you only are doing, if you only have one statement in a for each or for loop or an if statement, then you don't need the brackets. Once you have more than one statement, then you have to have the brackets. Okay, so let's go ahead and try this. So when I run this while I'm not recording, I can set this at 12 and still get hourly step validation. For the purposes of this demo, I'm going to ramp this up. And apparently I just changed where child lives. Alright, it hired all the employees. That might even be a little fast. We might want to adjust the randomness there. And then when the month changes, we should see these people start to be paid. We will bump it up even more. So we're at a day a second now. So our month changed. So let's figure out how much our CEO makes. So yeah, he was just paid 4,400 or 4,471 dollars. We can also see that he has a PhD in intelligence or an IQ of 113. And this is probably actually their pay after paying their mortgage. I think because all these people live in a really nice house, they ended up all getting jobs. So let's move out of the suburbs and see how many of these people are getting or have jobs. But yeah, so their monthly rent is getting taken out, but they do not have a workplace. Alright, this person has a job. But it looks like it's working for the most part. The next step would be to add more workplaces in and then figure out sort of like how they balance with the inhabitants of the city. And to do that, we can again modify our human data dump script and maybe even the population analysis, because that has a breakdown by residence type. So we could even have like percentage unemployed in here or something like that. Although the average wealth is somewhat telling. Alright, so yeah, that gives you something to play with, and until next time.